So one of the earliest techniques used in memory management is when you have lots of processes which have to be loaded in the main memory. The first technique used is this contiguous. So contiguous memory allocation is, so it is like this. There are two types. One is if you have the main memory like this, main memory, right? And now what people did is, okay, one part of the main memory is always going to contain operating system, no doubt about it, and in the remaining part we could put as many processes as possible, right? So one technique what they did is they divided the remaining part into equal sized partitions, or fixed size partitions, we can say fixed size partitions. And then they decided that a process, if it has to run, it should be loaded in only one partition and it should be contiguously present in one partition, then only it can run. So using this method, it is called as fixed partitioning. Fixed partitioning means the memory is divided into partitions. In this case, let us assume that the memory is divided like this, and the size of this partition is, let us say, 2 MB, and size of this partition is 4 MB, 4 MB, and let us say 10 MB, something like this. And all the partitions can be of equal sizes or different sizes. Then what happens is, whenever we want to load any process and run, we are supposed to load the process in only one particular part, one particular partition, and the process is not supposed to span over many partitions. So using such a kind of architecture, there are some few problems here. So one problem is called internal fragmentation. So internal fragmentation means, let's say this, let us say one process has come and its requirement is 1 MB, the process size is 1 MB, right? So what is the smallest fragment that, smallest partition that you could assign? In case if 2 MB is freely available, if it is not occupied by any process, then definitely you could assign 1 MB there, right? So what happens is the 1 MB process will be kept there completely and 1 MB will be wasted. So this 1 MB cannot be allocated to any other process. This problem is called as internal fragmentation. What is it? Internal fragmentation. So what is internal fragmentation is, whenever you have a partition and in that partition if you try to put a process and if that partition is going to have some extra free space, then you cannot fill that free space with any other process, isn't it? Therefore this problem is called as internal fragmentation. So one problem with this fixed partitioning is internal fragmentation. Then there is other problem. The other problem is, what is the maximum size of the process that could be run in this architecture? If a process is less than or equal to 10 MB, it can be assigned in this partition and it can be run. If the process is more than 10 MB, there is no partition which can hold it. Therefore, it may not be able to run in this architecture unless you use virtual memory. Virtual memory concept, we shall see it later, right? Therefore, other limitation is maximum size of a process may be limited by the size of the partition if you don't use either overlays or virtual memory concept, right? So one is internal fragmentation is there, and then there is limitation, on process size, right? And other disadvantages is that there is something called as external fragmentation. So external fragmentation happens this way. Watch it. Let us assume that in this 2 MB, 1 MB is kept and 1 MB is free, and is 4 MB, let us say 3 MB is filled up and 1 MB is free, and here also 3 MB is filled up because the process size is 3 MB and 1 MB is free, and let us say here 9 MB is filled up, right? So 1 MB is remaining here, 1 MB is remaining here, 1 MB is remaining here, and 1 MB is remaining here. All the free space put together, we have a total free space of 4 MB, right? And now even if a new process comes and if its requirement is 4 MB, even though we have 4 MB space freely available, we will not be able to allocate that 4 MB to this, isn't it? That is called as external fragmentation. So what is external fragmentation? Even though we have total free space available, we will not be able to assign it to a process because of the requirement that the process has to be contiguous. We are not allowing a process to fill up 1 MB here, 1 MB here, 1 MB here, 1 MB here. Our requirement is that if a process is present, it has to be contiguously present. It cannot be present in parts. That is the main concept of this contiguous memory allocation. So as long as we have contiguous memory allocation, there will be a chance of external fragmentation, right? So external fragmentation is there, isn't it? And the other disadvantage of this model is, one more disadvantage is, the degree of multi-programming is limited, isn't it? If you watch it, at any time, at maximum only 4 processes can be present because we have only 4 partitions, right? Therefore, the other disadvantage is degree of multi-programming is limited or fixed. Limited means fixed. It doesn't vary, right? So depending on the size of the process, or the size of the memory, nothing, it is not going to vary, it is going to be static like this. So these are all the disadvantages we have. So with these many disadvantages, people rarely use this. In 1950s they used to use this in mainframes, but later they moved on to other architectures. So even though we have this, this is called as fixed partitions, right? Partitioning with fixed partitions, right? So in this method we have so many disadvantages, so we are not using it now, and we used it very long back. So I'm not going to discuss anything further about it, like how the processes are allocated or anything. I'm not interested in discussing because it is never used, and definitely there are no questions on gate also. Okay, fine. So now because of this disadvantages, we are going to go on to the next one, which is dynamic partitioning, right? So we shall see how the dynamic partitioning works, and then we shall see in this partitioning method how the relocation and protection is going to take place, right?